Hi, here with Sagan. Yeah, what are we doing today, Sagan?
Doing the 201 electronic project kit.
Cool. Look at this. This is my original kit from when I was about your age, Sagan. How old are you?
7.
7. Awesome. This is the Tandy / Radio Shack Science Fair 201 electronic project kit. And this is my original one I actually had as a kid. This is, for those who want to know, this is how I learned electronics, or started out learning electronics. Wasn't actually this one. Did you know that I had the 50-in-1 first?
No.
Yeah, I did, but I don't have that anymore. There was the 50-in-1 was the first electronics kit I ever got. I was probably like 5 or something. And then I had the 150-in-1 and then the 200-in-1. But only the 200-in-1 remains. It's a bit tatty, but it still works. And how does it work, Sagan?
Wires.
Wires. We've got spring terminals, yeah? And we hook up all of the individual components. We're going to have fun, so we're going to build up a couple of projects from this, yeah? But I think we're going to have to strip some wire. So we've got some wire. Yep. Wire stripper. All right. Okay, so you're going to show us how to strip the wire.
So first, the tiny hole there, those tiny little gridded holes there, you just find the size hole that you think you need, put the wire in that hole about there, and then
ta-da! There we go, we stripped it. Well done. And now give it a little twist on the end so that, so just hold it in your fingers and give it a little twist like that. All right, Sagan, you're going to tell us about all the individual components on here. Go for it.
So in this 1 to 40 section here, where we've got the resistors, those little things there. Got the resistors, and on the 41 to 44, we've got I call them dodies.
Dodies?
Yeah, I call them dodies.
I used to call them diodes, but they're diodes, aren't they?
Yeah.
Yeah.
Silicon diodes, and then in the input transformer here in the orange section, then the output transformer in the other orange section, and of course the batteries in the green section, and of course you need the antenna.
Antenna rod, yeah. Yep. So you can build radios and stuff.
The antenna rod, the transistors in the other pink section.
What do we got here? What are these little brown things?
And we've got the capacitors in this other green section.
And capacitors, they come in two different types. We've got the brown ceramic ones and the blue electrolytic ones. I hope they still work after all these years.
Yeah. Fingers crossed.
What else have we got?
Then down this bottom bit here, we've got the turning orange bit, and the control orange bit, the meter blue bit, the LED digital display, light emitting diode, the select.
It's a switch, yeah.
The select switch, and we've got the key.
Yeah, which is just a physical,
just
a key. It's like a Morse code key. You just push down on it. Yep.
And then we've got the lamp, which is probably just down there.
There it is, that one, isn't it? Yeah, that's the lamp. There you go.
Right there. And then we've got the CDS cell.
CDS cell, that's a really difficult thing to say. That's a cadmium sulfide photo cell. So that's a light detector. It just detects light.
And then we've got the speaker down there.
Yep.
Speaker just there. And of course we've got T1 and T2, the terminals here.
The terminals. And these aren't the original LEDs on here.
No.
Daddy they actually had little surface mount ones actually recessed into there. And I don't know, I used them for some project and I replaced them with just standard LEDs in there so that I had from my junk bin. So there's our 7-segment display. We've got a control which has a switch on it. Nice meter. Look at that. Did we say the integrated circuits?
Oh, we forgot the integrated circuits.
Which ones have we got?
We've got the integrated circuit quad 2 input NAND, and the integrated circuit dual JK flip-flop.
And we've got a relay, and that's about it. So let's build a project, yeah?
Yeah.
Now the really good part about this, of course, is the not only like the spring terminals, which made it easy to do it, but the book, the comprehensive book that it come with me to the world of NOR gates, flip flops, transistors, and LEDs. Oh, trust me, for a like a 7-year-old Sagan's age, back in the, well, I won't say when, but back in the early days before the internet and before all the other distractions and gizmos, this is what the curious kids played with. It was really cool. Anyway, we have 200 different projects here, and then it starts by identifying all the components there, and then all about troubleshooting as well, building projects, getting started, keeping a notebook, and encouraged you to keep a notebook, which I did. Don't know where it is now, back in the day. And yeah, it was very cool. And
this is what it first looks like. Well, with all the terminals that I showed you. But then, after a few of these, it turns into that.
Well, it tells you there's a big change coming, because first of all, it just makes you build them up by route, basically, just like visually like that. And of course, you know, you don't get to learn about schematics, circuit diagrams, do you, Sagan?
Nope.
But now, turn the page.
Ta-da!
We can start learning about circuit diagrams, and they get more and more complicated. Well,
and
hopefully.
By 200.
Oh, there we go. Multiple counter.
By 200. Wait, right there. 199. 200.
200. And then explore, and it encourages you to explore electronics on your own. Fantastic. So, which one are we going to build, Sagan?
Well, we're going to start off very easy on the rain detector.
The number 4. So we're going to do it visually first, are we? Even though you know about circuit diagrams, don't you?
Yeah, a bit.
Yeah, here it is. Rain detector. That's the one you wanted to build, yeah?
Yeah.
All right. So it looks pretty simple. Look, there's not much in there. We're using our output transformer. Yep. We're using some capacitors, some resistors, and what else are we using in here, Sagan?
We've got transistors.
And we've got a switch and the speaker. So I think it's going to generate a tone. What do you think?
And it will detect rain, but there's no rain outside today.
So
no rain forecast, so we're going to get a jug of water instead.
Cool. And what do we have over here, just in case?
Just in case anything fails, we've got the fails and the easies that I brought out before.
Awesome. Let's do it. Go, Sagan. Let's wire it up.
Okay, so down here, the wiring sequence.
Oh, you're going to follow in the wiring sequence. I thought you'd just follow the visual. But yes, it does actually have a wiring sequence if you want to actually do it in order, but you don't have to do it in order.
Nah.
So you can just, but it was easy because I found that visually you would end up missing a few if you did it visually. So I think in the end I learnt the wiring sequences was a guaranteed way to get it, working, and then you wouldn't have to troubleshoot it. But as I've said before, the best way to learn electronics is to fail and troubleshoot it. So hopefully it doesn't work, Sagan. Then we have to troubleshoot it.
Yeah. Actually, I think I'm going to follow this. Okay.
Oh, okay. Yeah, it's pretty simple. Just follow it visually.
So 24 with a long one to T1.
So we're going to bend that back.
Yep. And
stick it in.
Wait a minute.
And twist it. Yeah, the ones actually that we got with the kit, they actually came pre-tinned. The wires were pre-tinned on the end. That was handy. So the stranded wires are a bit annoying.
Annoying that we made because Daddy lost a lot.
I lost all the wires, didn't I? Almost all of them. There's still some left.
Yeah, these white ones and these black ones.
Now we're doing the center tap of the transformer. There we go. That's called the center tap.
So
that's the negative terminal. You've got 2 wires in the same terminal now. which can get a bit tricky. You got to make sure one doesn't fall out.
Okay, I think I've got this. Got it. Then we go over to 51.
It's the center tap of the transformer. Cool.
There. If it comes out again. I got it.
You got it. All right. So we're connecting our speaker to the output of the output transformer. Yeah, that's called the secondary side.
Yeah.
So let's hook the other wire of the speaker up.
Okay. Oh, that wire's a bit gone, Daddy. Look at it.
Oh, that's gone. That's had
its days. Sorry.
That's had better days, hasn't it? Yep. Oops. Well, it is many decades old. So
many decades.
And I'm sure it was used to build hundreds of times to build up circuits.
Hundreds.
You've got a circuit building kit at home as well, don't you, Sagan?
My own.
It doesn't use spring terminals. It uses like big tabs and things.
It uses snap tabs.
Snap tabs.
But it still has like the same components.
Yeah.
It's
And what kind of gates do you know about?
The OR gate and the AND gate.
Yep. We're hooking up a transistor now. And that's the emitter. See the little E on there? Yep. That's the emitter of the transistor. But we can't see that because we don't really have a circuit diagram to work from because we're going visually, aren't we?
Yeah.
So, but when we had a circuit diagram, you'd be able to see it. What did you just hook up there, Sagan?
A capacitor and a transistor.
Cool. We connected the base to a capacitor here. I think we're building an oscillator, Sagan. We've got two capacitors in this circuit, and it looks like this capacitor goes back to the collector of the transistor.
Okay.
Another short wire.
We have no more lights. Right. So where again?
From there to the collector.
Oh, from there over to there.
Cool. And our collector of our transistor goes over to drive the transformer over here. So it drives the primary side of the transformer, it's called. Double contacts are tricky. I always had lots of problems with double contacts not working.
Where over to?
It was driving the low side of the primary of that transformer there. Oops, I thought that was an NPN transistor. It's not, it's PNP. See the arrow going inwards?
Yeah.
It's a PNP transistor, not an NPN. So that's why it's on the battery. The positive of the battery goes over to our switch, and then our switch goes to the emitter of the transistor, which is a high side transistor which drives the transformer. Cool. Now the trick I found with the double ones is not to put it on the same side because it'd always come out. You stick it in the other side so that this one couldn't fall out. So that's a little trick I learned. Okay, we haven't finished building the base of our transistor there, so that's got to go up to the resistors. So remember, put it on the other side. The B symbol there. Terrific. One more terminal of our transformer, Sagan, which is not hooked up. That's the high side of the primary. The transformer, where does that go?
Oh, I think I need a bigger one. That didn't fit.
I always found that the kit actually had it came with all different sizes. They were all color-coded, and you always had enough. You weren't left wanting from memory. They actually provided a good lot of
wires.
Yeah, with the right lengths.
And Daddy lost a lot.
I lost a lot of wires.
But then we cut off the right sizes again.
All right, I think we might be close to done, Sagan.
Okay, I'm going to press 2 easy to...
That was easy.
Of course, it used batteries, and I never knew this at the time, but of course we've got TTL transistors, of course, 7.4 series, and they were powering from over 6 volts directly from the batteries. There's no protection or anything from this. So let's go find some. I believe they were AA, Sagan. Oh yeah, there we go. Made in Taiwan, Radio Shack, a division of Tandy Corporation, Fort Worth, Texas. And I thought it'd be really cool to use my first multimeter. This is the Microna 22201U, 2 joules, 20k ohms per volt. Thank you very much. This is what I used with this actual kit when I was a kid. So I saved up my pocket money and this was my first multimeter and it still works. Unfortunately, it uses the 2mm probes. I don't have any, but I do have original Microna probes here, but they're standard 4mm banana terminals, so they don't work. But the good thing is, Sagan, look at this trick, mate. They actually go in backwards like that, so we can use them like that and then do this. So let's measure some batteries, yeah?
Found. And we only need 6 out of the 12.
We don't actually have any new ones around. We're completely run out. So we put this on DC volts.
Yep.
Yeah. So we go around to here. It's got 5 DC volts. Yeah. So when the meter goes all the way to the end, it's 5. You see how it's got from 0 to 5 on that black scale?
Yep.
DC. Okay. What voltage do we want? About 1.5. So you want it to go to 1.5, yeah?
Yeah.
So
1.5 or over is good. So let's.
well, they won't be too much over 1.5.
Yeah.
Okay. So let's try it.
Okay.
Let's measure one.
Because these are only double.
And you've got you've got the polarity correct. Let's go. Oh, look at that. Yep, that is 1.5 volts. That's over. So that one's good.
Ah, that's the good one.
Winner, winner, chicken dinner.
Yeah, that's a winner. Okay, let's look at this guy.
Oh.
Nothing.
Oh no, there we go. It's just dodgy contact. Try and press harder. There you go. That looks good.
Yeah, that looks
1.5 volts.
1.5 volts. Try this circle one.
Well, backwards.
Oops. Sorry.
That's all right.
I can never remember.
Yep, that's 1.5 volts as well. You see how if you get a dicky contact, then it sort of, the needle wiggles like that. And what you've got to do, because it's got a mirror on it, you see how if I tilt that, you can actually see 2 different, you can see the needle and the mirror image of the needle.
Yeah.
You've got to tilt it so that they line up like that. That's called parallax error, and you want to avoid that to get the most accurate reading possible on your analog meter. Yeah, that one's not quite, that's not too great. That's about 1.2 volts.
Okay.
See that?
Bah.
Other side.
Wait a minute. Well. Fail battery.
And of course we can test them, Sagan, a different way, can't we?
Yeah.
We can test them by, let's take this good one, and we drop it. And if it goes thud like that and doesn't bounce, then it's good. We already measured that one. This one here, we just measured as dud, yeah? Well, it was 1.2.
We'll try.
See? It bounces.
And what about this one? We haven't measured. It bounced.
Yeah. Do it again. Hang on. Yeah, it bounced. So that one we'll probably find, try it, we'll probably find is not 1.5. We'll probably find it's like 1.2 or 1.3.
No.
No, it's 1.5. Why did it bounce? That's interesting.
I think you better do a teardown
Ah,
video.
that's why. It's not bouncing. It's an extra heavy duty. It's not an alkaline. It's got different chemistry inside. So, oops, that doesn't work. But that one measures good, doesn't it?
Yeah, that's a good one.
All right.
Lucky last battery. Who will win? After that, I'm going to test all the others to see how they are.
Let's go to the 25 volt scale. The scales work great on this. Let's have a look. Oh, sorry.
So the black one goes there.
Yep.
Where does the other one go?
On that terminal there. And it is, so we're on 25 volt range and it's over on 5 volts. Yep. So we're good to go. Ready? Oh, actually, put it down. We'll turn it down to 5 volt range. 5 volts. Oh, we're actually 4.5. There we go. That'll still work.
Still
good
works.
to go.
Good to go.
That's interesting. It says 4.5 volts on there. Do they actually have a diode protection in there? I don't remember. We're going to have to take this apart afterwards. What do you think, Sagan?
Tear down!
Tear down!
But of course we're going to put it back
Okay,
together
Sagan,
because it's so beautiful.
All right, let's switch it on, Sagan.
Okay.
So we've got our control knob. Oh, it's already on. There we go. So switch it on, but it's not going to make a sound. Oh, I'm trying to, our rain detector, maybe my fingers aren't good enough. I think we might have to, can you get a wire and just short out those two there? It works, Sagan! Haha! It works, dude! Yeah, first go. Oh, that's a bit disappointing though. It means we don't have to troubleshoot anything. But let's put it in some water. Do you think it's going to work with the water?
Who knows?
Well, let's try it.
We might have to troubleshoot it. Put both terminals in the water.
Yep, stick both terminals in there.
That's interesting.
It's in the water. Yeah, it works. It works. Yay! So the water has enough resistance, or a low enough resistance, and it tells you in here somewhere. There you go. If you want to read the blurb about that particular circuit, it teaches you about that water is conductive.
Sounds like somebody practicing to whistle.
And what if you separate them? If you start them out far apart, try it. Hold them far apart and then bring them together slowly and see at what distance. It changes. Did you hear that?
Yeah.
It changes frequency.
And when they touch each other, and when it touches each other,
Oh,
hear that little sound?
what's going on?
When you touch each other, when the two,
Yeah, but it's gone lower volume.
because I'm touching them. The two
No, but it was louder before. So what's going on?
And now it's not working. And when I touch the two wires, these two little wires touch in the water.
It's gone silent. Something's happened to our circuit. Oh no!
Troubleshoot! Finally! This is what we hoped for, a troubleshoot!
What's our first troubleshooting step, Sagan?
Measure the batteries.
Measure the batteries. Yep, we're good.
We're good.
Okay.
We're good as gold. Try it again, See? When they
Yeah,
touch.
it's really low in volume, so just check all our wiring, because with a physical build like this, a physical circuit build, often a wire could have come loose, but it's still oscillating because it's still making a noise.
Yeah, but when they're not touching each other in the water.
Oh, there we go. Oh, Sagan, I think I found it. Look, this is one of the original wires. And I reckon it's got a dicky contact. So do we have another one? Okay, well, what we can do maybe is we can join two new ones. So you want to put that on there? And I'll put this on here. And we can join them together. We can actually put them into a terminal like this. It's called a floating terminal. Okay? So let's just put it in there. It doesn't matter. It won't hurt our chip because nothing else is connected. Now let's do it again. Try it. Try the circuit. Yay! We had a dicky contact, Sagan. And now put them right to the side. Yeah, it doesn't work. Moving slowly closer together. Whoa!
It goes like a very bad signal radio when they touch.
Yeah.
And the water. Huh. Do it again, Daddy. Do it. Touch them. Touch them. Very bad radio contact.
We can do Morse code. Cool. We did it, Sagan. Well done, mate. That was awesome work. And we got a little fault in there as well. That was an old dicky contact caused by my old wires.
Daddy, since we figured that out, that means we can add that into the book. Those two wires into the book. We can just it'd still work even.
It'd still work, yeah. But it doesn't, that actually doesn't change your schematic. So if you have one like a schematic on other pages like this, it wouldn't actually change, but it'd change your wiring diagram because you'd have different numbers, but the electrical schematic would remain the same. So, cool. Was that fun, Sagan?
Yeah. How about we just say part 2, teardown time?
Let's do it, Sagan. Tear down. So, can you undo these screws? Look, there's screw there, there.
Okay, I'll undo
There,
the screw.
here.
Time for
Actually, I'll join you. Let's go.
These aren't really too tight.
Nah.
And we will put it back together because it is a great kit, isn't it?
It is a great kit, isn't it? Yeah. You can. You can't buy this exact. I don't think you can buy this exact one. You can buy similar ones. That it's still called 200 in 1, but there's other companies that make them now. And I remember tearing this down as a kid. And of course, okay. Is that? Yep. Okay. You want to lift that up? Well, actually, grab the transformer there. Whoa. Here we go.
Look.
Oh, careful.
Oh, because we've got some.
There we go.
And even more wires underneath.
Yeah.
Oh.
They all go to the front panel. It's a little bit how you're doing. Wow. Look at that.
That's the easiest teardown.
Pretty easy teardown. And
Not much. It's just a battery box and thousands of wires.
yeah, that's about all it is, isn't it?
And
Not
a few
much.
weird sticky up bits.
You can see that the IC is on its own little circuit board down in there. And
It's all cardboard.
It is cardboard, isn't it?
Amazing. It's just cardboard.
Yep, that's all it is. Very cheap construction. But it works wonders and it's held up for all these decades and it still works. It's a great kit, isn't it?
Yeah.
How does the 200 in 1 Science Fair electronic kit from the late 70s and early 80s, is that a thumbs up or a thumbs down?
Double thumbs up. Actually, I'll do it for 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hooray!
And what do we say at the end of the video, Sagan?
Catch you next time.